So welcome to the first video where we are going to the first step of building of working with LangChain and using the tool calling feature. Let me close this README. I will go through this again. So the code that I have open here, can be found inside the GitHub repository. Of course, you will find the link on the description below. There's a subfolder called tool calling, and inside the tool calling folder, there's a subfolder step by step. In here, I have broken down the basics, this basic example in 4 steps, so that you can we can walk through each part of the process and see what's happening step by step. So I'm going to start by going through step 1, and this is the code that is contained in the basics 01.js. In here, this is a very simple setup, so we're just importing a few components, a few packages, and we're setting up our very first language model. So let me go through what is happening in this file. So first of all, we're importing a library called Zod. Above the of its import and above some of the lines in the code, you will find that I have placed some comments. So this is taken from the documentation. So Zod, if you don't already know, Zod is a schema declaration and validation library. It allows us to define certain schemas. I will go through a simple, quick example. And not only validate, not only declare, but also validate these schemas during runtime. I have an example in here. Basically, this is the simplest example I can come up with for Zod. Once you import Zod, you can define a schema using the Zod.method syntax, so z dot and the methods that are available from the Zod library. And in this case, for example, I'm defining a schema called my_schema, which is just the simplest schema possible, which is a string. So in here, I'm saying that the schema, the type of the values that will adhere, that would conform to this schema, should be of type string. So first, we define our schema in Zod syntax, and then we pass a target value. In this case, tuna and 12. We take the my_schema object, and then we use the parse method, pass it the target value, and then the Zod schema will either return the value, which means that it parsed the value and it's adhering, it's conforming to the schema. It is a string, so we can use it. Or if it doesn't conform to the schema, in this case it's a number, it's not a string, it will throw an error. And another example, which is slightly more advanced. In this case, I'm defining an object schema with one property called username, which is of type string. So basically what I'm saying here is I want the schema to have this sort of like structure. It will be an object, it must be an object with a property named username, the case is sensitive, and then the type would be string. Once again, I create my schema using the Zod syntax. I'm storing this in a variable, and then through this object that is created, I can use the parse, pass 2 different values, 2 different target values. This one is an object that contains the property username, and the value of the property is string. So this would be okay. But if I pass an object with a property username and a number, I will get a Zod error. Of course, if I type something like this, I will also get an error, because it does not strictly conform to this schema. The username is all lowercase and not camel case, so it will also produce an error. So that's roughly what the Zod library is doing. Now let me focus back on the import section. The next thing I'm doing is I'm importing a helper method from the LangChain core library, which is called tool. So from the tools, I'm importing tool. The tool we will go through this later, is a helper function that will allow us to dynamically create a tool from a function. So basically, if we want the LLM to reach out to a function in our code and then execute it, we'll have to use this helper method. Simple functions, simple JavaScript functions just don't really work. We have to use this special tool. So that's the tool, what the tool import is all about. Then I'm going to use a chat model from the Ollama library. I'm using Ollama, so I'm importing this chat Ollama class from the LangChain Ollama package, and this will allow me, of course, to use an open source chat LLM through Ollama in my app. Next, there's another import, the human message from the LangChain core library, once again from the messages. So messages in general, there are different types of messages: human message, system message, AI message. We will see some of them in the process. So as the documentation states, messages are the unit of communication in chat models. They are used to represent the input and output of a chat model, as well as any additional context or metadata that may be associated with the conversation. And a human message, this specific one that we're importing, it represents input from a user interacting with the model, because we have other types of messages: system, AI, and so forth. So this one is intended to be used by to create a user input. So these are just the 4 imports that I'm including in this file. Next, I'm configuring a model. So based on the models that on the LLM models that you have downloaded through Ollama, you can pick one of these and you can set it here in the model. So when you instantiate a chat Ollama model, you will use this model. I'm using the Llama 3.1 version, and the way that you can check what models are available is you can run Ollama list. If you already have, of course, your Ollama installed, and you will see that I have downloaded quite a few LLMs here, and this one is the Llama 3.1 latest, and this is why I'm using this one. Of course, I can pick another LLM model, or I can download and use another something like Mistral and so forth. So I pick the Llama because it's pretty good. Then these are some settings. This is going to be the server, the Ollama server URL, and then I'm setting the temperature to be 0. So temperature, as the documentation states, controls the randomness of the model's output. A higher value, like 1, makes responses more creative, so we get a different response every time we ask the same question, while a lower value, like 0.1, makes them more deterministic and focused, more predictable, let's say. So with temperature 0, given the same question, we will probably get exactly the same answer. So that's how we set up and instantiate a large language model using the Ollama class from LangChain. And next, I'm just going to invoke this language model, which means I'm going to ask a question and get a response back. So I'm going to open up the terminal. I'm already in my tool calling folder. So I'm in the tool calling folder. I have a package.json. I have the step-by-step folder here. So the first thing you have to do is you want to run npm install, so that you install all the dependencies that needs to be installed in order for this application to run. So run npm install. I have them already downloaded, and I'm going to run this first step to see what comes out of this LLM. So I will run this. It's going to take a while if your Ollama server went into hibernation mode. So it woke up and it gave me an answer about what a Petri dish is. So it seems to be working okay. I can also say what is a JavaScript set, for example, just to make sure that I get and we get sub output that talks a little bit about the JavaScript sets with some examples and so forth. So far, the LLM seems to be working fine. Everything is working fine in this code. And up to this point, what we really did was just use an LLM to a programmatic, let's say, interface. So we're just using the chat Olama to be able to invoke, to ask a question to the LLM, get back a response, and then use it in our code. Now, in here, I was just console logging the content part of the response. This is the text message that we get, but apart from the content, you will see that I get quite a few information back from the LLM. So I get a bunch of information along with the content, so you can take a look at what's inside this response. Something that's really interesting at this point to see is these two properties. So apart from the content, which contains the response, there are these two extra properties which are now empty: the tool calls and the invalid tool calls. These are related to tool calling, which is something that we're going to see in the next videos. So that's the end of part one. Just a very basic setup of LangChain, instantiating an LLM model, asking a question, getting a response back, and then we're going to continue. So hopefully I will see you in the second video. See you there.